Yeah. Okay, so my talk will mainly be about my major work in one of our projects, which is dealing with first responders and IT, introduction to the processes of first responders. And before I will give you a short introduction of my research group at Fraunhofer. As far as I know, there have been some other talks here which were dealing with Fraunhofer fit, because there have been many other exchanges. So I will more focus on our group. And sorry. So our group has just got a brand new name because we had some restructuring. It's now called User-Centered Ubiquitous Computing, and this shall already show what we are doing. This name consists of actually two parts. The first part is user-centered, which is referring to we're doing, first of all, human-computer interaction, and we try to involve users as early and as often as possible in our development process. So we're trying to do user-centered design. The second part is ubiquitous computing, which you might know. It's all about having small computers in everyday devices, trying to make this vision of Mark Weiser come true, where everything is connected and everything is kind of intelligent. So we're dealing with mobile platforms and investigating how new devices can be used and can be interacted with. We have actually three parts where we do this user-centered ubiquitous computing. The first is basic research in this field, and it was coming from one project which was called which was called Hydra, and this was about having something that puts different heterogeneous devices together, that helps to connect them, because as there are many different devices from different manufacturers around, everyone has a different standard, and it's really hard to connect them. So we, in this project, which we were coordinating, we were trying to build a middleware which shall help developers to be easier, to make it easier to interact between different devices. And I have a small demo which hopefully shows a little bit the main idea of Hydra. What you see here is a picture, a webcam broadcast from one of our partners in Sweden. In Sweden it's night, so that's why it's dark at the moment. And but on this picture there are some devices which I can now switch on from this website. For example, there's a disco ball, and I switch it on, and you see on the webcam image that the disco ball is running now, gives us some light. And then, for example, I can also switch on a small train, which you can see here. So actually that's the main idea. Connecting everyday things, connecting different kind of devices, and connecting them over different networks. Although this is done from a website, but in this middleware we have done some SOAP tunneling functionality, which helps to being able to interact over different networks and being able to connect over different networks.
Are you going to turn the train off?
Oh well, it's just running for some time, so but I can turn it off. Oh well, okay. You see the disco ball is now off, but I can also switch it off, and you can see the actual energy consumption here, which is also something that we're dealing with. So I don't want to have the train running the whole night there. Okay. And we have now some new projects because Hydra ended last year, and we have some new projects which shall extend the middleware. Then the second field is energy efficiency and smart environments. This is actually more a domain where we want to apply this ubiquitous computing, and this is most about saving energy. Energy can be saved in actually 3 different ways. You can make something in an automatic way, like if everyone leaves the room, the lights are shut off automatically. Or you can use more efficient devices, like exchange your old washing machine by a new one. Or, and this is what is interesting for us, you can help people to save energy. And we want to investigate how ubiquitous computing can help people to save energy, and we want to make some innovative approaches here. I've also short video which can demonstrate this well, I hope. It's about the concepts that we are using, and this is actually one of our demo. So one of the concepts, for example, in this demo is that we have some light here, it's an ambient light at the back of a desk, and this shows when there's waste of energy. So for example, my colleague has just opened the window, and here you see a heater, so you have a heater on and the window open. This means there's potential for saving energy. So we have some light turning red here. And the concept behind this is that we did some user questionnaires, and we found out that users actually want to save energy, but they are not often really sure how to save it, and they don't want to be taught like this. You have to do it like this. So it's more they want to have it quiet and calm in the background. And this was one of our ideas, to have a light. And if you're sitting at your work, and this is also one thing that they taught us. If they work, they don't want to focus on energy saving. They just want to focus on their work. So if you're sitting on your PC and you have some light in the background, after a very short time you don't notice it anymore. But if you don't concentrate on your work anymore, you have some break, you do some other thoughts, then maybe you can notice it, and then you can see, oh, there's potential for saving energy. And then you can go on, and the rest of our application will help you a little bit more. This is a little bit about technology. We are using Arduino sensors. These are sensors for measuring energy consumption of pluggable devices. And we have an Android application, and this is also some concepts that we are trying to implement. It's about telling people what they can immediately do, and doing this very short and very precise. Like you can investigate why is there some potential. Then you can see in this application the light is on you and you have left. That's the reason, and it already tells you what to do. Switch off the light. I mean, it's not very complicated, but it's the concept behind it. Just some short introductions, what you can do, and something that you can do very fast. And we also implemented to do this very fast. Again, a remote function call. He switched off the light now from the mobile phone. Okay. So now I'm coming to the actual main topic of this talk, and this is about the third area of our work, and this is actually one project, the project Bridge. The project Bridge is about exploring the process of first responders in large emergencies. So our focus is on, we first want to understand how do first responders work, and then we would like to introduce IT and ubiquitous computing to improve the processes. And since we think in this field of first responders, it's really important to know how the requirements are. We have a really big focus on that, and we actually have one single work package. This is our work package, all about requirements engineering and user requirements. And well, actually, this is what this is the main work that we have done so far in this project. It's a large project. It started this April and will last until 2015. And there are 14 partners from all around Europe. Okay, to give you an idea how first responders work, I will show you some pictures. This is actually one of my colleague. I think this is my colleague. And he took this, or another guy took this picture in one of some former related projects. It's from a training site of firefighters. Firefighters do training very often to get used to some processes. They have to train it over and over again. And so they have some training sites, and my colleague was invited to take part in this training. So what you can maybe guess already here is that well, firefighters' work can be dangerous for themselves compared to our work. I mean, if we are sitting in front of a PC, usually nothing happens, nothing really dangerous for our lives. But their life is in danger more often than ours, let's say. But on the other hand, they are also trying to save the life of other people, and because of that, they are under pressure, under emotional pressure, but also under time pressure. If it's lasting too long, maybe some people have died already. And on the same time, they are in an unknown environment. Situations can be very chaotic, or are usually very chaotic, and I mean they often come to a place where they never have been before, and although they have been to some place maybe, it can look completely different because some thing is broken, some landmarks are not there anymore or look different. So that means it's really important for them first to get an overview and to get an idea what happened and what that location is all about. But they have, I mean, there are not many informations available. They are usually incomplete and they are also unreliable. People told us that they come to a location and there are some bystanders that tell them, okay, it happened like this, and then they come to another bystander and that one tells it was the other way around. So they don't know what's really the truth. But I mean, that's the only information they have, and well, it's important to get an idea of what happened in order to save the life of some patients. But this is Utøya. You maybe heard about that. This is a Norwegian island, and there was in July there was a gunman that went onto that island and shot 69 people. And yeah, I mean, I think this gets a good idea when you put yourself into the situation of a medic that comes to that island and he doesn't know. Well, is the gunman still around? Did he work alone? Where are all the patients? What happened to them? This is really, yeah, you're under high pressure, and you have to. Your body has to work. You don't have to. You may not think about what to do next and sit together and discuss. It's not like this. You just come there and you have to work like you've practiced before. This is another picture from fighting training, and yeah, this is also a good example. Often you just cannot see anything, which is again something which shows, well, it's a different kind of work environment than in other areas. And because of those work environments, those first responders already have started to build their own tools. Here you see a string, and this is also completely dark. they cannot see anything, and they use the string to find their way back out of the building. So they take it inside and they get out of the building like this. Okay. So here's another tool, and this is what we are trying to improve. And the process here is called triage. Triage is when you're coming to an emergency site, to a large-scale emergency site, you usually have many patients, and you don't have the resources to treat them all at the same time. So you have to decide which one to treat first. And what first responders do is the very first responder that comes to that place goes to every patient and does a really short first diagnosis. So he, for example, it's about 15 to 30 seconds. He, for example, measures pulse and respiration rate, and does some short first diagnosis and writes it on those paper tags. And then in the end, he also assigns a category. There are 4 categories, and what he does is he cuts off the categories that are not fitting. So, for example, if he thinks one has to be immediately treated, he cuts off those, so that the red one here is the last, and then he attaches the paper tag to the patient, so that second responders who come to that place can look out for first for the immediate patients, and they treat them first, and after every red patient is treated, they treat the yellow ones, and so on. Okay, and we think that there's much space for improvement in this process, because it's like this: when the second responders come to that place, they still don't have an overview where all the tagged patients are. They have to maybe to go to everyone and have a look at that tag. I mean, it's already good, but it would have been better if they have a clear overview and immediately know where to go. So improving the overview and having a faster access to the overview, or being faster able to get an overview, this would be an important goal. And at the same time, could be important, or would be most probably important, if the data would be available in digital form, because the data is used by different people, which are located at located at different spots. For example, you have the one who's in the field who treats people first. Then they have some other medic, maybe in the ambulance van, and maybe some other doctor in the hospital, and they all may need this information. So if it would be available in, at the first triage process in digital form, it could be distributed to all the other people, and they could know in advance. But since there are so many, since the work environment is so harsh and different, there are many constraints which we want to take into consideration, and this is, well, as I told you, since you have to just work and to perform how you've learned, it's very important that the process is in your mind and just works, and so our aim should be to not change that process so much. Actually, the less we change it, the better it is. It may be people told us that if we have something that really improves the process but changes it too much, they wouldn't use it. And related to this is that we need simple kind of interaction. It shouldn't be like you have to think about, well, to which menu point do I have to point to find that functionality. It best would be well, a device with one button or with no button at all. Best would be if the device could know what the user wants to achieve without having to interact at all. And also having not too much information, because it also makes no sense if you have to have a look at it and have to to understand your device for 1 minute before you can act. You just have to have a look at it and then go. Okay, so we have built a first prototype, and this is a first idea which we showed our user group, and this is consisting of 2 parts. This is the first part, which is actually a colleague of me doing, and he tries to investigate how this triage information can be put into an electronic form. And his first idea was that he takes the normal triage tag and he puts RFID tags on the back side, like this. And the first responder is equipped with an RFID reader somewhere in his clothes. Also a GPS is integrated in his clothes. And then he does the triage process as before. And as soon as he cuts off the non-used parts, you can see that some of the tags are also cut. And this can be used as a trigger. We now a patient has been tagged, and we also know that the category to which he has been tagged, because I mean you cannot read those 2 anymore, but you can read those 2, so you know which category it was. And then you have also a timestamp, and via GPS you have a location. So this is very smart with regard to the process that of triage is not changed at all, but now you have category, time, and location information in a digitalized form. But there's also another approach, and this is, here we changed the process, but we get more information. So we need to investigate which is better. These are some electronic tags, and they should not replace those paper ones, but could be attached to them. They can be set to some category. You can see here the different colors. Well, actually it should be black instead of blue, so that you have the same colors as on the tag. And you can combine it with some other sensors, like vital value sensors, so that you can also get respiration, pulse, whatever you need. Okay. And then, my part is then more focusing on how the second responders can access those triaged informations. For this, I've also done a small mock-up, and this is again just not some huge thing. It has very small functionality. You just have a map, and you have an icon for every patient, and it is worn like this. You have it. It's hanging around your neck. So actually, it's hanging here like this. Because we found out that this area for first responders is actually not used. You can put things like IT things here. So actually, I used to have some case here, which I have in Germany, so I can show you. But usually it's hanging like this, so people don't need their hands. But if they want to have a look at this, they can just grab it and have a look at this. And it's moving. The map is always heading towards where I look. So actually, this is this thing of you don't have to do some interaction. You just move. You just do, and this is the interaction. The application already knows what you want to achieve, kind of. And then the last thing is that you can access the information for each patient, And what you probably also can see is we try to stick to those symbols that are already known. We didn't provide very much information, only the information which is the most important one. Yeah, and the only interaction is here to go back. So what we've done so far is we went to we did a first user workshop, and we presented those ideas to firefighters, medics, policemen, and while we haven't analyzed the results complete, but we have some preliminary results, and this is the last thing that I'm going to show you. There have been some interesting statements, and this was, for example, that they first of all like the idea, but they think the people that are doing the treatment, they don't need this. It's not so important for them, but it's more important to have for some in-field command center. They usually have one who's in charge on the field, and for this person it could be very interesting to have such an overview, because all the other people are coming to him and he's directing, he's commanding, okay, you go there, you treat this guy, you treat that guy. So this is interesting because well, actually for this person it's maybe not so important that the device can be handled hands-free, because I mean he has some space, he can lay the device somewhere and grab it when he needs it. So this could give us some more possibilities for the design. Okay, then what the people also told was this category is actually not very well. It is important, but the most important or the more important thing is actually the two values of pulse and respiration. They interpret the values anyway, so actually they don't need this category before they have the information about respiration and pulse. And this can also influence our design. For example, instead of having those icons, those colored icons, we can just show at the locations a respiration and pulse rate. Well, this should be easy to handle. Yeah, there were also, as I said, there were some police men, and they were also interested in other information that could be integrated, not only medical information, but for example, the policeman said, well, for us it could be interesting if we know that there are some drug dealers or murderers around, and then we can first of all warn the medics or go with them to take care that nothing's going to happen to them. And maybe this could also be integrated. Another possibility for this is maybe there are some dangers at the site. A gas station is going to explode, and if you know that, it would be also good to inform those medics. Then the medics really need life values, which they don't have at the moment. I mean, they have some re-triage, but actually they have the values from the first triage, the value from the second triage, and then people are already in the hospital. But your vital values can change all the time, and they wanted to have some live updates and maybe also some alarming if some vital values are going under a certain threshold. Like saying, okay, here pulse rate is below 30, you have to take care of him now. So this is more an argument for the second choice of triaging. When you compare this to that, well, then maybe this is better because you can access vital values here. And the last one, and this is interesting because this is actually what Mark was also planning to do here. The command centers would like to have some live pictures from the site, because people have to work together, and they have to collaborate, but they are at different locations. There's a command center, there's the on-field command center, there are responders with the people, and they have to collaborate, but they well, can talk to each other over radio, but they don't really get an idea. Especially the command center doesn't really get an idea what's going on the field. But if they would have some live video stream, see what people in the field see, they told us this could be very valuable for them. Okay, yeah, as I said, this is our preliminary results. We are currently investigating or analyzing this first user workshop any further, and yeah, so actually if you have any questions, it would be a good time to ask now.